So we're going to look at factoring by GCF and grouping. And so first things first, we'll look at GCF, and they relate to each other. So if you get GCF really well, grouping should come pretty easily. So first things first, if you are factoring out a GCF, you probably should know what a GCF is, and it stands for the greatest common factor. And so if we break that down, the greatest is just the biggest or largest. Common is what do these things have in common or the same. And then factor is a number that is multiplied into a bigger number. And so we're looking for the biggest number. Or variable or exponent that goes evenly into each polynomial term. And so you've definitely seen this before. If you have xy to the third, x to the fourth, y squared, x to the third, y to the fourth, you're trying to take out the biggest thing possible. So first off, you should notice that they all have the same variables. All of them have an x, all of them have a y. Do they have the same number? No. Well, that's where the common factor comes into play. So I'm going to go really in depth into this one, and then we'll pick up the speed elsewhere. So we've got 1x and 3 y's, 4 x's and 2 y's, 3 x's and 4 y's. So if we're taking out the GCF, we see that we have an x in each of them. Can I take out any more x's? Well, here I can take out more x's, but here I'm all out of x's. So I can only take out 1x. And then the next one, I can take out a y in all of them. Can I take out another one? Yes, I can. Can I take out another one? Well, I can in these two, but I'm all out in this. So I can only end up taking out a total of 2 y's. So that's basically what the greatest common factor is. Really, really early on, you learned it just by using numbers. And so here we're just using it with variables and numbers. So next example, if you have 40a to the 5th minus 24a to the 3rd, we need the biggest number that can go into 40 and 24. And so if you need to, off to the side, you can list out all of your factors. So we know that 1 goes into both, but there's probably something bigger. Well, 2 goes into both, but there's probably something bigger. 3, nope, not both. 4 goes into both. 5, nope. 6, nope. 7, nope. 8, yeah, that goes in. And I think that's the biggest one. So we're going to take out an 8. 8 goes into 45 times. 8 goes into 24 3 times. So that's pretty good. And then we've got a to the 5th and a to the 3rd. Well, how many a's can we take out? You can make the connection that whatever variable you take out, it's going to be the one with the smallest exponent. So we can actually take out 3 a's. So my GCF is 8a to the 3rd, but since we're factoring it, we have to fill in the rest of the polynomial so that it's still equivalent to what we started with. So this is kind of our reverse multiplication. So 8 times what gives me 40? 5. I took out 3 a's, but how many are left? I need 5. I took out 3, so I have 2 left. Keep the same sign. So 8 times what gives me 24? 3, and I took out 3 a's, and I started with 3 a's in this term. So I don't need any more. And that's factoring by GCF. We took out the GCF. We wrote the rest as a factor. So we've got a couple more examples. Negative 15, a to the 3rd, b to the 4th, plus 25, a squared, b squared, minus 20, a, b to the 5th. And so this one, your leading term starts with a negative. So when we have this, we want to take out a negative with your GCF. So now we've got three terms, so we're looking for a number and the variables that go into all three of them. So we're going to take out a negative, and then what number goes into 15, 25, and 20? What's the biggest number? 5. Each term has an A. We can only take out the smallest number because eventually we can't borrow from anywhere. So this one only has one A, so we're only going to take out 1. And you can use that trick. It's always going to be your smallest exponent. And then each of them has a B. B squared is the smallest exponent. So my GCF is a negative 5AB squared. To get back to my original expression, to keep it equivalent, we're going to multiply negative 5 times what to give me negative 15? 3. I took out 1A. I need 3. How many are left? 2. I took out 2 B's. I need 4. How many are left? 2. So then when we multiply my GCF by this first term, we get the first term. So then we're going from negative 5AB squared to a positive 25A squared B squared. So negative 5 times what gives me 25? Well, a negative 5. I took out 1A. I need 2. So I need 1 more. I took out 2 B's. I need 2 B's, so we're good on the B's. And then we're good for that term. So then we'll look at this final term, so negative 20AB to the 5th. So negative 5 times what gives me negative 20? Positive 4. I took out 1A. I need 1A. We're good on A's. I took out 2 B's, but I need 5, so I need 3 more. So again, my GCF is negative 5AB squared, and this is the rest of my factors to make sure we have an equivalent expression. Remember that if there's a negative all the way in front, we always want to take out a negative with the GCF. And you can always, always, always check your answer by multiplying. So if you're much more comfortable with multiplying than factoring, you can always use that to your advantage. So next example, we've got 6x squared plus 3x, a little bit simpler. And so we're looking 6 and 3, what's the biggest number that goes into them both? Well, 3 goes into them both. It's kind of weird because that's the coefficient of that second term, but that's okay. And then they both have x's. Well, how many x's can I take out? Just 1, matches the smallest exponent. So that's my GCF. And then I've got to fill in my factor. So 3x times what gives me 6x squared? Well, 3 times 2 gives me 6. X times x gives me x squared. So think back to that product rule. So x, exponent of 1, same base, exponent of 1, 1 plus 1 is 2. And then what we notice is that the GCF matches this term over here. So 3x times what gives me 3x? Well, anything times 1 gives you itself. So here's another note. When the GCF is the same as the term, use 1 as a placeholder. And then I've got one more example for GCF. And this is one where I'm going to write it out, and if you want to pause it and see if you can do it by yourself, this would be a great one to try that with. So we got 3 terms, we got some A's, B's, and C's, 6, 15, and 12. I know that the biggest number that goes into all 3 of those is A, 3. I know I can take out at least 1 A, at least 2 A's, and that's it. I can take out 2 B's, and I can take out 2 C's. So my GCF is 3A squared, B squared, C squared. Kind of catchy. And then I'm going to fill in my factors. So 3 times 2 gives me 6. I took out 2 A's, but I need 3, so I need 1 more in here. I took out 2 b's, I need 4, put 2 in here, and I took out 2 c's and I need 2 c's, but I'm good to go, I don't need any more. So if we look at the next term, so 3 times what gives me 15? Positive 5. A squared and a squared, those are the same, I don't need any extra a's. B squared and b squared, I don't need any extra b's. C squared and c to the third, oh, I need one more c. And if it makes you feel better, you can put a 1 there, but it doesn't really change anything. 3 times what gives me a negative 12? Negative 4. I took out 2 a's, but I need 5, so I need 3 more in my factor. B squared to b to the 5th, I need 3 more. And c squared to c squared, they're the same, I don't need any more. So there's my GCF in factored form. The coolest thing about GCF is it's the first kind of factoring that we really learn about, but we use it until the end of time. So when factoring, you always take out GCF first. And so this is one of those big bad things in your notes where you want to star, you want to arrow to, you want to highlight, underline, circle, whatever, so you know that it is super important. Write it in all caps, always, and I'm sure we'll remind you when we start factoring other things, but just in case. All right, so let's look at grouping. You factor by grouping when you start with 4 terms. So that's the big thing here, is 4 terms. So in this first example, obviously since we're just learning grouping right now, they're all going to be 4 terms, so you don't really have to check, but when you learn other factoring methods, you'll need to. If you really like to follow steps, I'll write out steps for this. So first thing, we're going to create binomials. And that just means we're grouping in 2, so 2 terms. And then 2, we're going to factor out a GCF from the binomial. And then that last step is factor out the common factors, common binomial factors. And so I know that's a lot of words right now, but it'll make sense in just a second. So, factor by grouping, it gets its name because we put the first 2 terms together by grouping them with parentheses, and we put the second 2 terms together by grouping them in parentheses. And so then that's step 1. Step 2 is factor out the GCF from each binomial. So x cubed and 9x squared is my first binomial, and we're going to take out a GCF. Well, what do they have in common? They have an x squared in common. What's left? X squared times x gives me x to the 3rd. X squared times 9 gives me 9x squared. A squeaky chair. And then we're going to do that same thing for the second binomial. So 2x and 18, they have a 2 in common, so I'm going to take it out. And then they have an x plus 9. At this step, you can already know if you did it correctly or not. You got an x plus 9 in both sets of parentheses. That's how factoring by grouping works. You know you did it correctly when you get the same thing. And so since they both have x plus 9, you did it right. And so this last step is just saying factor out the common binomial factors. So you've already got another thing in common, that x plus 9. And so your final answer, you're going to repeat that x plus 9 one more time. Basically, you're factoring it out. Mathematically, that's what you're doing. And then you're going to put your outside stuff, x squared and 2 together. So x squared plus 2 is the other factor. And that's your final answer. I think it's pretty cool. It's pretty mathematical. All right, so I've got a couple more examples factoring by grouping. That is 3x to the third plus 6x squared minus x minus 2. How many terms do we have? 4. So we know we're going to factor by grouping. We always want to check to see if there's a GCF. There is not. This term ruins it for us. It's a 1, and 1 doesn't really have a GCF with anything other than itself. And so we'll follow our steps. So we'll put the first 2 together, the second 2 together, and then we'll take out our GCF. So 3x to the third and 6x squared have a GCF of 3x squared. Fill in my factor. 3x squared times x gives me 3x to the third. 3x squared times 2 gives me 6x squared. So just like factoring out the GCF, told you they were similar. Negative x and negative 2, remember that when we take out a GCF and the leading term is negative, we want to take out a negative. So we're going to take out a negative. X and 2 have nothing else in common. If it helps you feel better, if it helps you sleep at night, we can take out a 1. And then we've got a nice little placeholder there. If not, you can just leave it as a negative. And then inside we've got an x plus 2. You know you did it correctly because your factors inside the parentheses are the same. And our last step, factor out that common factor. And then put your other stuff together. So 3x squared and a negative 1. Yeah, that's your final answer. So I've got a couple more examples for you. If you think you've got it, you can go ahead and do the homework. Next one is 12n to the third plus 2n squared minus 30n minus 5. We have 4 terms. We always want to check to see if there's a GCF in this one. 12, 2, negative 30, and 5. That 5 messes it up. It's the only odd number, so there's no GCF. So we can go ahead and group our first 2 together and our last 2 together. And then we'll take out our GCF. So between 12n cubed and 2n squared, I can take out a 2n squared, and it leaves me with a 6n plus 1. So notice my GCF and my 2n squared, this term, were the exact same, so I use that placeholder of 1. Anything times 1 is itself. Logically, it makes sense, but it's still kind of tricky to notice. And the next one, we've got a negative 30n and a negative 5. Since the leading term is negative, we do want to take out a negative with our GCF. This one does happen to have one of 5. And then hopefully our factor is going to match the other factor that we already found. And it does. So last step, don't forget this. You want to factor out your common factor again, and then put your other stuff together. So 2n squared minus 5. All right, 2 more examples. 12xy minus 24x plus 4y minus 8. It is 4 terms, so we know we're going to factor by grouping. We always want to check to see if there's a GCF. So between 12, 24, 4, and 8, imagine that. There's a GCF. What is it? It's 4. So we're going to take out a 4, and we're going to leave it with a 3xy minus 6x plus y minus 2. So in your final answer, you want to make sure to include this 4. And so we can leave it hanging out in the front this whole process if you want to, but really it's just important to remember to bring it back down at the very end. So we're going to factor by grouping just the stuff in parentheses. 3xy minus 6x has a GCF of 3x. That leaves a y minus 2. Now this y and minus 2 don't have anything in common except for a 1. I'm going to use a placeholder in front so that I don't forget when I'm combining my factors in the last step. And it leaves me with a y minus 2. They already match. We're good to go. Technically speaking, we need to have this 4 out here, so we'll put this in big brackets. And we'll have our 4, and then we'll have our first factor 3x plus 1 and our common factor y minus 2. And I have those big brackets just because in the last one I wanted to make sure we remembered to bring that 4 down, that initial GCF, but your final answer can look like this as well. Your order does not matter. And I've got one more example. So 15x to the 4th minus 15x to the 3rd minus 20x squared plus 20x. Do they have a GCF? Definitely do. It is a 5x. So if you forget to take out a GCF, your answer just will not be simplified all the way, and you'll just be dealing with really big numbers. So if we take out a GCF first, then you'll just have smaller numbers to be dealing with, which is always nice. So if we take out a 5x, that leaves me with a 3x to the 3rd minus 3x squared minus a 4x plus 4. And so same thing, if you have that GCF out in front, you do want to make sure to bring it down with your final answer. So since we've got 4 terms, we will factor by grouping, and then we'll take out some GCFs. So this first one, my GCF is a 3x squared. That leaves me with an x minus 1. And the next one, since it's a negative leading term, we'll take out a negative 4. Leaves me an x minus 1 as my factor. I'm going to put all of that in brackets, keep that initial GCF on the outside. Bring it down, take out my common factor, and then have my 3x squared minus